In this video, we're going to look at an application of solving inequalities. So let's read the question. The amount of water in a service truck steadily decreases with the amount of time the sprayer is turned on. Okay, so you should try to visualize this situation. Okay, get an idea of what's going on here. So there's some sort of truck, a service truck. And imagine that it's filled with water, to whatever height they fill service trucks with water. Okay. And this said that the amount of water in the truck steadily decreases with the amount of time the sprayer is turned on. So this truck travels around and sprays water on, I don't know, trees. Okay, so it has some sort of hose or sprayer. Okay. And as the sprayer is turned on to do whatever it does, you can imagine that the water in the truck would be decreasing. You could think the height in the truck would be lowering, but also the number of gallons in the truck would be decreasing. Now let's look at the specific information they give us next. A full truck can hold 4,000 gallons and decreases at a rate of 528 gallons per minute. Okay. So the initial amount of water is 4,000, and as the sprayer is turned on, for every minute, it loses 528 gallons of water. So now we're asked to complete the table below. Okay? So we're given two variables. T equals the time the sprayer has been on, measured in minutes, and we have W equals the amount of water in the truck in gallons. And they explain that the longer the sprayer has been on, the amount of water decreases. Okay? So let's figure out some exact values given specific values of time in minutes. So notice we're looking at a variable as a changing value instead of a specific value. We're going to find how much water corresponds to 0 minutes, 1 minute, 2 minutes, etc. Okay? So now the sprayer has been on 0 minutes. So you probably know the full truck starts at 4,000, so it's tempting to just put 4,000, but we're going to put a little more information here. So we're still going to relate it to it decreases, so we're going to subtract off 528 gallons per minute. Well, 528 gallons, and for 0 minutes we'd multiply the 528 times 0, and notice the result is still 4,000 gallons. Now, if the sprayer has been on for 1 minute, we'd start with 4,000 gallons, and we'd subtract off 528 gallons per minute, and we'd multiply that 528 times 1, since it's been on for 1 minute. So now let's compute this value. 4,000 minus 528. And I'm going to multiply that by 1, even though that's just 528, just to show the structure, is 3,472 gallons. When the sprayer has been on 2 minutes, we start with 4,000 gallons. We want to subtract off 528 gallons per minute for 2 minutes, so 2 copies of 528 gallons. So 4,000 minus 528 times 2 gives us 2,944 gallons of water. And finally, after 3 minutes, we start with 4,000 gallons, subtract off 528 gallons a minute for 3 minutes, and that gives us 2,416 gallons of water after the sprayer has been on for 3 minutes. Let's look at the next question. Use your work in the second column to write an equation for finding W. So there's our second column. So we're finding an equation for W, where W represents the amount of water in the truck for N, I'm going to put this in green, an arbitrary value of T, the time the sprayer has been on. Okay, so we computed our W, so we're going to write W equals Okay, and notice it said to write an equation, so you don't just want to write an expression like we have here. We want to write what W equals. And now let's look at the pattern. So this is why I want you to always write your expressions like this in your tables so you can see the structure. Okay, so looking at these, it's not obvious what operations we should do, but looking here, you can see. So notice, in every case, we start with 4,000 gallons of water. In every case, we subtract. In every case, we multiply 428 times some value. And what changes here is the value we're multiplying by, 0, 1, 2, or 3. Now, where did we get this 0, 1, 2, 3 from? That corresponded to the time in minutes. Okay. So when we write our equation for W, if we want to write an arbitrary one, and that means we want to write an equation no matter what t is, we can use this equation. We would write W equals 4,000 minus 528, and we multiply that by the value of t. We'll just put t right next to it, okay, to show that we're multiplying by t. So let's look at the next question. The truck operator wants to know during which minutes, I'm going to put that in green, during which minutes the truck will hold less than 1,300 gallons of water. And we want to write an inequality to represent this scenario. Okay, so let's look at our equation. So we made an equation, not an inequality, that said the amount of water in the truck is equal to 4,000 gallons minus 528 gallons per minute times the number of minutes the sprayer has been on. Okay, so this is an equation. Now we want an inequality that shows us when this water, which equals this expression, will be less than 1,300 gallons of water. So I'm going to put less than 1,300. Now, notice this looks a little bit weird. We have an equation and then we have an inequality. Okay, so we really want to know, because it said during which minutes, we really want this expression on the left-hand side to be written in terms of t, not w. So I'm going to rewrite this as 4,000 minus 528t. We want to know when that is less than 1,300. Okay. Now, there's a reason I specifically wrote this way, and here's why. Okay. Lots of times when we're solving equations, so let's look at something like this. If we started with this equation, we'll say maybe find the t value for when the water is exactly equal to 1,300. Okay. And in that case, we'd replace W with 1,300, and we'd solve for t. Okay, so now we have an inequality, which, remember, inequalities are not symmetric. So suppose we replaced W with 1,300, and then I'm going to put 4,000 minus 528t on the right-hand side. Okay, if you read directly at the instructions, it says less than 1,300, so it may be tempting to just put a less than symbol here. Okay, but notice how that's not appropriate. Over here we have this computes the amount of water, and it is less than 1,300. And we showed in another video that if you want to reverse the side in which the expressions are relative to the inequality symbol, you need to change the direction of the inequality symbol. So this would need to be written this way. Okay, so this represents the amount of water in the truck. So 1,300 has to be greater than 4,000 minus 528t. Or you could write it this way. 4,000 minus 528t, the amount of water, has to be less than 1,300. So these are equivalent inequalities. Okay, but because inequalities are not symmetric, you have to be careful. So what I recommend is you really focus in on the structure. Okay, rather than using this replacement idea, which you can use, you just need to be careful. Okay, look at what it says. Wants to know during which minutes the truck will hold. Okay, so it's talking about the minutes, so you want to use the expression involving t, and then you can use the directly less than 1300 because it develops that way in the sentence. Okay. In the next video, we're going to do parts D and E.